Wideband ADC front-end design amplifier drive versus transformer drive. Introduction. Design of the input configuration or front-end ahead of a high-performance analog-to-digital converter (ADC) is critical to achieving desired system performance. Optimizing the overall design depends on many factors, including the nature of the application, system partition, and the ADC architecture. The following questions and answers highlight the important practical considerations affecting the design of an ADC front-end using amplifier and transformer circuitry. What is the fundamental difference between amplifiers and transformers? An amplifier is an active element, while a transformer is passive. Amplifiers, like all active elements, consume power and add noise. Transformers consume no power and add negligible noise. Both have dynamic effects to be dealt with. Why would you use an amplifier? Amplifier performance has fewer limitations than those of transformers. If DC levels must be preserved, an amplifier must be used because transformers are inherently AC-coupled devices. On the other hand, transformers provide galvanic isolation if needed. When do you need to use a transformer? Transformers offer the biggest performance advantage compared to amplifiers at very high signal frequencies, and when significant additional noise cannot be tolerated at the ADC input. How do transformers and amplifiers differ when providing gain? The main difference is the impedance they present to the ADC input, which directly affects system bandwidth. A transformer's input and output impedance are related by the square of the turns ratio, while the amplifier's input and output impedance are essentially independent of gain. What are some considerations in this analysis? One must start understanding the level of difficulty in designing a front end for a given ADC. First, is the ADC internally buffered or is it unbuffered? For example, a switch capacitor type. Naturally, the level of difficulty increases as the frequency increases, in either case, but switched capacitor types are more difficult for the designer to deal with. If gain is needed to make full use of the ADC's input range, an application that might otherwise favor a transformer becomes more difficult as the required gains turn ratio increases. Of course, the difficulty increases with the frequency. IF system below 100 MHz with a buffered ADC would be relatively simple compared to a high IF design with low signal levels using an unbuffered ADC.
Different सगळं लावायचं आपल्याला कुठल्या बुकमध्ये हिरवा आहे ते कनेक्टेड असतं फक्त ते प्लग लावायचं हा एक घेतलेला आहे आणि हा इकडचा आहे ना हा इकडे बघ हे ही वायर आहे ना ती इकडे कनेक्टेड आहे.
What are the important characteristics of the ADCs that I may use? The popular CMOS switch capacitor ADC does not have an internal input buffer, so it has much lower power dissipation than buffer types. The external source connects directly to the ADC's internal switch capacitor sample and hold SHA circuit. This presents two problems. First, the input impedance varies with time and as the mode is switched between sample and hold. Second, the charge injected into the sampling capacitors reflect back onto the signal source. This might cause settling delays for the passive filters in the drive circuit. Conclusion: when facing a new design, remember to understand the level of design difficulty, rank important parameters in your design, include the ADC input impedance, and the external components in the input circuit when determining the total load of the transformer or amplifier. When choosing a transformer, always remember, not all transformers are created equal. Understand transformer specifications, ask the manufacturer for parameters that are not given and or not modeling. High IF designs are sensitive to transformer phase imbalance. Two transformers or balloons may be needed for very high IF designs to compress the even order distortions.